upon. So, yeah, somebody who has helped me started recording. Thank you for recording. About the confidence interval, let me try and share my desktop because I'll be moving from one document to the other. Let's see desktop here. So I think you can see the slide, right? You are seeing my desktop, right?
Yes, doctor.
Okay. So I said we will start from having an exercise on confidence interval. So when we talk about confidence interval, we are talking about the range, the assurance that a certain range of numbers will always repeat itself at a particular confidence level. 90%, usually in social sciences, 95% is also always choosing. And 95% means that if you are repeating the same exercise, 95% confidence that you will be getting the same thing. So if you want to know the confidence interval, so we want to look at the range within which we know that 95% of the scores we are getting for a particular item or a particular characteristics will fall within certain range. So that is what I want to demonstrate by finding the confidence interval using the formula we have here. So I'll show you my Excel sheets. So I've built up this data. I think you can see, is it big enough for you to read?
Yes, doctor.
Okay, so I stated here that on confidence interval, use the age distribution in the table below, find the confidence interval at 95%. So I just tried to import the formula for the confidence interval so that I will not be going back and front. So what do we mean by here? What we are saying is that 95% confidence that we are going to get the average mean of the ages. Then, if you want to get the interval, we want to know age bracket that will fall within the 95% of standard deviation. So that was why I was trying to use the standard deviation mark to explain this confidence interval the other time. So from our formula, we know there's something we call set score. Don't mind me, this one's supposed to be insert plus or minus, but I just decided to write it this way. And maybe I can, let's see if I can quickly correct that and put and insert a plus or minus sign here. If I can find it on the symbols. It's supposed to be a plus or minus sign. Insert symbol plus or minus. Okay. Insert close. Yeah. So that is done. So we are looking at statistically the Z alpha divided by 2. What it means is that we're expecting a 5% error margin if we are saying 95% confidence level. So the error will not go beyond 5%. So what it means is the Z score alpha over 2 is saying that at 5% error, the scores will center around the mean. That means 2.5%, 2.5 to the right, 2.5 to the left. So that is why it is a 5% range that will give you 95% confidence level. So if you want to find the confidence interval, we need to calculate the mean, get the standard deviation. So when we have the mean and the standard deviation, then we can work out the confidence interval. This Z value has been calculated for 95% confidence level. The Z score is 1.96. It's an established statistical fact. So we will now put in our figure into this formula and look at the range within which these ages that will fall within 95% of our confidence level. So to find mean, we all know age now become the x, that is the value, x, y, the number of students is the frequency. That's the number of people that have that score. Then we will need to find our fx. So I hope someone is okay, is doing that. For us to find fx, we get fx so that we can get our mean. And remember, in order to get the standard deviation, we will get x minus by x, right? We will need to find our x minus mean. So then we can call this x minus mean as something like, let's say d. Then we get d square. We are going to square the difference. I'm just creating the table so that we'll fill the table now. We'll get d square, d raised to power 2. Then we'll get fd raised to power 2, fd raised to power 2. So these are the information we need to work our mean and our standard deviation. Is that correct? Do we understand that? So let's go. This will give us 3 multiplying 18. So we can copy this all through. Okay. And we get the summation. Okay. And our mean, let's okay, I think you can hear me. So the internet, so the mean is this, which is the summation of fx all over summation f. So this is the mean age. So when we look at this age distribution among 48 students in a class, we get 20.56 as the average age. Now we need to fill in this place. This is x minus this, but since this is going to be a constant value, we put $. And this is what we got. Okay, so I do it across. This is what I get. So we square this. This raised to power 2. Yes, and the same thing all through. Okay, then this one by frequency. This multiplied by the frequency. Okay, and this goes through the way. Okay, Control C, Control E. So to get our standard deviation, that will be this square root of this divided by the frequency. Okay? Variance will give us this divided by this. Okay. Let me insert another. So our standard deviation, SD, give us the square root of this one. That's this raised to power 0.5. Raised 0.5. So this is 1.4, approximately 1.4. Is it clear how we got to the standard deviation now? Let me make this one 2 decimal place so that the number of decimal points will not be too much. 2 decimal places, and this one 2 decimal places. Okay, so that means our standard deviation is 1.4. So is anybody cross-checking that?
Yes, doctor, you're right.
Okay, now we have gotten our standard deviation, we've gotten our mean. I told you, okay, maybe I could put this information here that said this value. Let me see if I can copy and paste it somewhere and give us what the value is. Because I say it's a statistically established value. This value equals 1.95, 96 rather, 1.96. So let me do this. Subscripts. Okay, so we know that this set value is equal to 1.96. So we fix it into our equation. Let's see how we go with the equation. Insert more. So our confidence interval CI. Remember, we are going to get 2 values, plus or minus. So we do the minus first, then plus. So our confidence interval will be between mean. We put in our mean, which is this value, mean, minus the z-score. That's brackets open. We open the brackets, z-score multiplied by our standard deviation, which is this, and everything divided by our frequency, n, total frequency now, by this. Bracket close. So that's 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, and the second one, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51, 20.51 when we now put the positive, mean again, this is mean, now plus, bracket open, as z-score, this, multiply by the standard deviation divided by total frequency. 20.51 to 20.615. Let me see. Is there anybody cross-checking?
Doctor, I'm lost. How to calculate the Z A over 2?
Oh, you know, Z, the A over 2 is a reminder. It's not said A over 2, but this is how it's expressed, the z-score. So the z-score is telling us that, okay, let me quickly use this one. You know, what we are doing, follow this standard deviation distribution. So the z-score is saying 5%, when we are talking about 5% error level. So what we are now saying, the 95% confidence level here, the scores will fall within the 95% error level, confidence level. So this is the mean, mu. And we are saying that 5% error level will spread this mean both to the right side and to the left side. What does it mean is that we are looking at where these numbers are clusters. A lot of these scores, where they are. So from between this value here and this value represents the 5% error level. So the alpha you see there is 5% error. And if you divide the alpha by 2, that means to the mean 2 alpha divided by 2 to this side plus alpha divided by 2 to the left side. That will give you the 5%. So some literature will put it 2.5%, 2.5%, instead of writing alpha over 2 or alpha over 2 here. They will tell you 2.5% to the left, 2.5% to the right. So the error should not affect more than the total 5%. And that is what is giving us the 95% confidence level. So it is not mandatory that you put alpha over 2. But when you say z-score at 5% error level or at 95% confidence interval, then statistically they know that the 5% is spread around the mean. Does that explain it?
All right, thank you, Doctor.
Okay. So let me see this. I expected the figure to be more than 20. So I want to see what was the expression. Okay. Oh, square root of n. Sorry. Square root of n is sort of n. I'm sorry. So this will have been, let me see this expression, which if it's correct. Okay, this is another, okay. Please square roots of n raised to power 0. Okay, let me see this one. This is negative. Okay, this now is addition. Add to this. Let's correct this too. Square root, because there's square root there. Raised to power 0.5. So something else. Okay. So we have a confidence interval that's showing that those 95% of our score, 95% of our score here is supposed to fall within 20.17 and 20.958. This almost 20.958 is almost 21. So, and this is almost 20. So let's try and look at our scores from 20 to 21. We have how many of these? That is 32%. This is 32%. So this 32%, is it representing 95% of these 48 scores? So this is what we are going to look at if this is correct. I'm trying to check this again. So set score 1.96. Set score D16. This is mean. F6, yes. Multiply by this is, yes, it's correct. The equation is correct. So let's look at 32%. I want to see if this, because this is 20.17 to 20 to 21. We are believing the 32, those who are within here should be about 50, about 95% of the students will be having a score of 20 to 21. So if any score that is outside 20 to 21, that score is outside the confidence interval. So the difference between these two forms the interval. So this is what we use in order to look at the confidence interval, to know which scores are falling in between our 95% (20.56). 95% of the age fall closer to 20.56. So if this is the average, then majority fall within 20.7 and 20 and 21. So that is the confidence interval analysis. Now, if we see it in statistics, what do we explain? The confidence interval shows that majority of the ages of the students fall within 20.17 and 20.958. That means they are so clustered around the mean. They are not so far away from the mean. So if we have a confidence interval that is this close to the mean, then we say that the ages were distributed closer to the mean. So there's not much difference between the ages of the people in the class. So no much difference between the ages of the majority of the students in the class. So is that clear about confidence interval? Because we can have, maybe you look at the exam, find the mean, find the standard deviation and the confidence interval. So this is what is expected to be done, to know the interval, how cluster are these around the mean. So do we have the confidence that these scores are around the mean? Yeah, question now. Question time. So any question again?
Currently no question, Doctor.
Okay, at least we know how to calculate the confidence interval now. In case we are to calculate the confidence interval, at 95% confidence level. I will send these Excel sheets in the spectrum later, but I just want to know whether the steps of getting the mean, the standard deviation, and the confidence interval is clear. Is that clear?
Yes.
Okay. So if that is clear, then let's try and demonstrate the correlation too, so that the correlation too will be clearer. We can, after doing this manually, we want to do now, maybe next week, I will teach with SPSS application, because instead of doing it manually, we can just do analysis on SPSS, and correlation will be, we'll see the correlation, we see the regression. And from there, we can now pick values and interpret them. But at least for today, let's try and see how we can do it manually. Though I'm not doing it manually 100% here, I'm using Excel, but we know what to do if we want to do manually by which one do you want to multiply. Because during the exam, your calculations will be marked, not your Excel sheet. So I hope the one for standard deviation, for mean, median, mode, all those ones are clear now, up to the confidence interval. Can I get a yes or no answer?
Yes, it's clear.
Okay, good. So let's quickly move to how we can calculate for the correlation if we are to do it manually. Because if you are going to do manually, we would like you to calculate the correlation coefficient. So how to do the coefficient calculation? I want us to demonstrate it again today. So for that, I have this table I'm trying to create, but I'm not too conversant about the age, about the weight, because I want to use height and weight, so that we look at the relationship between the height and the weight of people, maybe in the class or some other set of people, so that we try to have an idea of how the weight or the height determines the weight. How can we use the height to determine the weight? So I have a set of height here in feet. 5 feet, 6 feet, 12 feet, 4.4 feet. So this is in feet. And I think I need weight to be in kg, in kilogram. So can you give me weight to fill into this cycle? Kg, in kilogram. So let's say the first one has a weight of how many? 35 kg. I'm trying to be conservative. 42, 36, maybe 44, 40, or maybe 51. It's hypothetical. I'm just bringing it out hypothetical so that we reuse it. 46, 53, 55, 48, maybe 50, 55, maybe 59, 59, 61, 66. If we have 48, 42, 557. This one is 60. This one is 55. This one is 83. 5. This one is 72. This one is 80 or 81. I think we can use this kind of data. So this is the weight, and this is the height. So we want to know the relationship between the weight and the height. Relationship between weight and height. So we need to find the correlation coefficient. So I go to bring it the formula we want to use. And I think Excel can even do correlation. So let's try and we pick these, either this or this, which is the same thing as this. Which one do I pick now? Okay, let me pick this. Control C. Somewhere. Okay. Can it be a control B? Oh, too big. Too big. Okay. And then we can see the format. I just put it here so that we'll know what we are looking for. Okay. So we need to find the mean of the age. Okay, let height be the x. And okay, we are thinking that height will be a determinant of the weight, or vice versa. Since this is correlation, so one will be x, one will be y. Just to represent them with this with what we are looking for, so that we compute the table and we try and analyze. So let this one be our x, and this one be our y, because there are two, or x1 or x2, or okay, our y. So we need to find the mean, average height, average weight. Remember, we are going to get up to finding the standard deviation or the variance. So we use this equation here to look for whatever we want to find. Here we need to look at the fx. Luckily, this one doesn't have multiple frequencies and everything. We can just find the x straight here. From here, we can find the average, right? Let me put the average here, because these are the things we need. So that's the average, I think. Okay, average height is 4.7, let's say 4.71. Okay, mean. Then we need the same thing for the other side, Control C, Control V. So an average weight is 52.45. So what we need to do now is to look for x minus mean of x. X minus mean. Then the same thing we'll do here, y minus its mean. Then we square them. So differences of x raised to power 2 I'm just using these terms to differentiate them. I believe you understand what they stand for. 2. Then differences of y raised to power 2. Differences of y raised to power 2. d dash y raised to power 2. So I think these are the parameters we need from this formula. Is that all right? Do we understand that?
Yes, sir.
Okay, thank you. So let's this minus C47, but there will be a string there, $sign to make it. So this is 1 point. Okay, what is the average of that? Okay, 4.71 minus 3. Okay, that's correct. This is correct. So let's copy across the board. Okay. I think our n is 20. So let me see. Okay. Now we want to do the same thing for mean. This is D, that will be D47. This is this minus D47, $47. Yes, 35 plus 47.5. Yes. I just want to cross check 47.45. Okay. 52 minus 35. Correct. So I copy this one to across board. Sorry, it seems my internet is fluctuating so much today. Hello? It seems the internet is...
Doctor,
Yes. It seems the internet is
you-
fluctuating.
if you add all the x mean, x minus mean, what is your answer?
X minus mean.
Then you total summation.
That is likely to be, I've not done that. I'm looking at I'm going through the equation. I want to know the summation that is there. It's likely, this is x minus bar x multiplied by y minus bar y. So you multiply it before. Okay, let's look at what I'm doing here. This, which is D, okay, which is dy, this will be multiplied by this before the summation, okay? I don't know where are you there? This difference, x minus mean, will be used to multiply by y minus mean, and you get them here. You don't total like this. You don't total x minus mean, then y minus mean, okay? So this will be we multiply each other first. And remember, when you use this one to multiply this, some negative will cancel out, right?
Yes, doctor.
Okay. So that is because the summation sign is not like this one. The one under, there are differences between where you sum. You multiply first before you add up. So this one, let me give this label dx so that will be easy to recall when we want to multiply dx, something like this. Just to make the, because there are symbols, I don't want to be going through the symbols so that we'll move fast. So we'll do this one square, right? One by one. That is this one raised to power 2. This one raised to power 2. This one raised to power 2. Okay? This raised to power 2. This raised to power 2 as well. Power 2. Okay. Let's fill this column. This. Okay. Let's fill this one too. Okay. Now, what else do we need? We need to sum this, we need to sum this, we need this multiplied by this. So let's say dx multiply, okay, I'll write like this. Dx multiplying dy. Is this one okay? I hope you understand this column now. This is the difference between this one and this difference multiplying each other. So this goes like this. This multiply this. I got yes. So let's fill the column. Okay, now we begin to get the sums. I think I can copy this. We need this, Control V, this, Control V, this, Control V. Can this be? Okay. Yeah. So now, let me see if I can put this one down. So now, we want to apply this formula, right? We have gotten the sum for this top. This is the sum. Oh, sorry. I need to do, this is not the sum. This is the average. Let me quickly put sum somewhere here. I'll try and, this is D46 from where? Where am I starting from? C27 to 46. C27 to 46. C27 to 46. C27 to 46. C27 for G. Sum. G 37 to G 46. G 27 to G 46. Okay. Bracket close. Okay. Control C, Control V, Control V. Okay. Let me reduce the decimal places to 2. Decimal places to 2. Okay. This one, decimal places to 2. Okay. Sorry, these are the totals. I want to, so that we can remember, these are the totals. Okay. So I don't need this. I don't need this. I don't need this. Remember, what I did here was to get the average. Please, this is average, so I don't need this. I need the sum total. And these are the totals I need now. So my R equals, let's now fix our formula. This is the summation of x minus y multiplied by x minus by x multiplied by y minus by y. This is the total here. I think this one is clear. Hello, class. These totals, are we okay with it?
Yes,
Doctor, can you move up to the first column?
Okay.
Check the formula, the formula, not the
Okay.
formula, the label, the label.
The label, yes. No, yes, this is where we are. This is the height, this is the weight. This is the scores of height minus the mean, deviations for the height, and this is for the y. So here, when we have this deviation, we need to square this, then we need to square this one too. Then in our formula, you know, there's this one multiplied by this. That is column E multiplying by F. And that is what is put in column I. Is the label okay now?
Yes, doctor.
Okay. Now we need this total, which we have added. We need this total. We need this total. Is it okay now? So that we can go and fix the formula, right?
Yes, doctor.
Thank you. So when we get here, so for summation x minus bar y multiplied by y minus bar x, this is the summation. Okay, maybe I put that one red. Okay. For summation x minus bar x, this one, maybe I put that one blue. And summation y minus bar y square, maybe I put that one another color, maybe green. Okay, so we need this for this. We need this 13.05 for this place, and we need this 25.96 for this place. So it's like getting the square root of this, multiply it together, and use it to divide this. So, is that okay? You know, I'm not in a board that I will write the formula. I want to put in the figures. Can I go on?
Yes.
Okay. Now here we have this divided by, I want to open brackets now. The bracket will be so many. Let's see, brackets, another bracket, another one, okay, just two. Summation x minus by x square, which is this. Multiply summation y by y square, which is this. Yes, after multiplying the two, okay, the whole thing is raising to power 0.5 because the square root. 5. I think I got it clear. Oh,
Doctor,
yeah.
when the formula inside is wrong already.
That's what I'm trying to check.
D53.
D53
Yeah,
is wrong.
Should be I48.
Oh, it should be I48. Let me see. Oh, how did I pick? Sorry. How do I pick? I thought I click on this. I53, right?
I48.
Okay, I48. Okay. I48. Okay. Okay, let's see. Let's see the formula again. I48, yes. Then all of them are 48, 48, yes. I48, H48, G48. Okay. Thank you. Now, let me put this one to 2 decimal place. So this is 0.81. So our correlation coefficient is 0.81 from this sample. So what it means is that the weight and the height have a very strong, this is a positive correlation, have a strong positive correlation because as the height increase, the weight increase. That is what it's saying, and the relationship is about 81% strong. So let's look at our data. You can see that not every time that the age is increasing, that the height is increasing. Let's look at this. At this, let's start from 3.5 height. We have weight of 35. When it is 3.6, we have the weight increased to 42. When it's 3.7, the weight decreased to 36. So this shows that not every time that an increase in age, an increase in height lead to increase in weight, or it is not a situation that the taller you are, the heavier you are. In some situations, a tall person may have a smaller weight or a lower weight. So but majority, according to this data, their height, the taller they are, the heavier they are. That is the majority. So 81%. So that means the remaining 19% effect of height on weight or weight on height is being controlled by another thing, maybe the feeding. For example, feeding can be something that can add to weight, irrespective of your height. So what this is saying is that height only determines weight 80%. There are some other things that can affect the weight, or weight can be related to height 80%. Other factors can bring in the difference of this 90% out of 100. So for such a correlation is strong and is high. So you can now deduce that the taller you are, the heavier you will be, according to this distribution. If the correlation coefficient is negative, that means an increase in height will bring a decrease in weight. But because this is positive, an increase in height will give you an increase in weight most often. So that is the function of correlation, whether the height and the weight are related. If they are not related, you will get 0. When correlation is 0, there's no relationship. When correlation is 1, perfect 1, it means an increase, 100% increase in height will lead to 100% increase in weight. But with this example we have just worked out now, 100% increase in height will lead to 81% increase in weight. So 1 unit increase in the height will lead to 0.81 effect on the weight. So this is the interpretation of correlation. Although the calculation may look complex, but the exact thing we want to know is that whether the relationship is positive or negative, whether it is strong or weak, or whether it is moderate. So maybe a person of moderate height, if it's moderate height, will lead to a moderate weight. But here we have found out that the taller a person is, the heavier he or she will be, at least by 81%. The remaining 19% could be as a result of other things, maybe eating fatty foods and all other things. So this is correlation calculation. Do we understand the calculation of correlation now? Yes, class?
Yes.
Is it clear now?
Clear.
I know on Tuesday when we were just it looks like clumsy. But at least it's just the explanation behind it that we did that day. This is an expression of how it is calculated, the correlation coefficient. This is how it is calculated when you want to calculate it. So all you need to know is the formula. What are the parameters you are looking for? Express them on the table. Fill all the columns, get your additions, and put the clumsy now. So class, is it clear? So that next week we will use SPSS to demonstrate it again, so that you just click and you go. Because I need to introduce you to SPSS package. So somebody told me it was clumsy last year. I want the person to answer now. Are you clear with it now? Because I know I promise that when we do calculations, maybe it will be clearer. So I can't remember the person who made that comment last time. I want to be sure you are clear now. Are you? If you are in class. Okay, can we move on?
Yes, sir.
Okay, so I believe it is now clear. So let's look at how we can do for regression, so that we find the slope and as well as we find the intercept, A and B. Remember our equation there. So maybe we can use this one too to try and find the slope as well as the intercept, so that we know. Let's believe now. Let's have our hypothesis will be that our function, regression function, will be that y, which is our weight, is a function of the height. So that means the height determines the weight. So height will be our independent variable, while weight will be our dependent variable. Now we are saying weight is depending on the height. Do you understand that? So if you understand that, we can equally use this data set to find out the linear relation equation, the linear regression between the weight and the width and the height. So let's look at it, and let me go and bring our equation to find those slopes And from there, we can now see what do we really need to put into our expression. Okay. Let me just scale this down. It's an image. Okay. Let's. Can I draw it all? A bit. Okay, so that we'll know what parameters we need. Here, I hope you can see the formula I brought in now. Here, the slope B is this summation x minus by y multiplying y, so y minus x, summation of x multiplied by x multiplying y minus by y. So we have that already. This is here. Then we need summation of x minus by x squared. I think we have that. This is x minus by x squared. We have that summation already. So we just place them on each other. So fixing the equation so that we get the intercept. So then summation xy, we need something here. Okay, okay, y by square. Okay, this is simple. So can we go ahead now? Remember in this equation, I'm not sure whether you are seeing it big enough or do I expand it? Okay.
We can see the formula.
Okay, you can see summation x minus by x multiplying y minus by y. We have it already. This is it, right?
Yes.
Good. Then we have summation x minus by x raised to power 2 already. This is this. So because it is x that is predicting y. So let's put this into it so that we get this slope. And here we can now substitute the slope into this equation so that we get what is the intercept. So all we need are available here. So for our regression, B, under the regression, we are looking for the slope. Find slope first. Slope which equal B. Now doing that, I want to call this is the summation. Okay, let me bring the formula down so that you'll see again as I'm picking it. Okay. Yeah. So from here, we can fix in the equation. Now, this summation divided by this summation. So what it means is our slope equals this divided by this, which is 11.45. I make it 2 decimal place so that we, okay, 2 decimal points. Then having found B, the intercept, which is A, equals, this one's supposed to be equals, not plus. So this A, when we look at this information, A is telling us that A will be equal to mean of Y minus the slope multiplied by mean of X. This is the mean for Y. This is the mean for X. So multiply by mean for X will be multiplied by the slope because it is a function of this. So let's go. This equals mean of Y, which is this, minus, I open a bracket for this multiplication, B, this is our B, the slope, multiply by the mean for X, bracket close. So we got minus 1.44. Let me make this 2 decimal place as well. Okay. Regression. I want to see if I can write this regression equation. This is equal to our regression Y equals A plus BX. So this is the regression line. Y equal to A plus BX. Now we have gotten A, we have gotten B. So our regression line, if we want to write now, will now be Y equals, what is our A? Minus 1.44 plus, what is our B? 11.45 multiplied by X. Now, this is our regression line. First, the slope, 11.45. The interpretation of 11.45 for slope means that when the height increases by 1, maybe by 1 feet, the weight is expected to increase by 11.45 kg. 1 feet increase in the height will give addition of 11.45 kilograms in weight. So now, however, we have a slope that gives us a negative 1.44. What does this mean? It means when there's no height, there's no weight. When there's no height, there's no weight because there's no negative weight. But what it translates to is that if there's no height, no weight. When you have 0 height, there's a 0 weight. And does it sound logical? anything that you don't have a weight for, a height for, may not have a weight. That is what he's saying, because we are referring this one to human beings. So when there's no height, when there's nothing to measure, when there's no height, that means there's nothing to measure height upon. And if there's nothing to measure height upon, where will you have weight? On what are we going to get a weight? So no height, no weight. So, but if you have one, your weight will be so small. And I think when we are talking about human being self, if we relate this to human being, no matter how small a human being will be, there will be a height, there will be a weight. If you are referring to objects with no height will not have a weight. But no matter how small is the height, then we begin to know what will be the weight. So we have related this exercise to the height of a human being, because that's what I was looking at. If you look at it, you will see that what I choose as height ranges between what will be the height of a human being. We normally say the maximum height is 6 feet. So that's why I didn't go more beyond a height of 6 feet. But if it is an inanimate object, if we are talking about inanimate object, then the appropriate measure and appropriate weight can come in. And you know, this illustration we have here is hypothetical. We just compute it in class. It's not a measurement we have taken from, it's not an empirical measurement. So, but this is to demonstrate the relationship between height and weight, and how we can put it in regression. How we can do that in regression. So do we understand the regression and the regression equation now? So let's ask question about this now. Any question? Any question?
Doctor,
Yes.
so look at your Excel sheet. Y negative 1.44 equal or plus?
Y negative. Again.
Back to your Excel sheet, Doctor.
Yes. For the
equation for Y, the last one.
The last statement. Okay, the last expression.
Yeah.
This Y equal to minus 144, 1.44, right? Is that the one you are talking about?
Yeah, and then equal to 11.45.
No, it's supposed to be plus.
Okay.
This, I'm trying to write this equation following the regression equation. 1.44, which is the slope, plus B, which is 11.545 multiplied by X. That's an error. Okay. Minus 1.44 come from the intercept, which we have just calculated, which is a relationship between the mean of Y and the mean of X. So when we look at the regression equation that this one, I want to bring it closer so that it will be within the regression area. And let me make it bigger. Okay. So looking at this equation that says A, the intercept, is a function of average of the Y, which is the dependent variable, minus the slope, multiplying the average of the independent variable. Here, our X here is the independent. So here is Y. So average of Y is 52.45. And that was what we have used to get the value for A. So with this, we get this average minus our B multiplied by the average of X. And that is why we got this. Now that we have and we have B, we can substitute them into the regression equation. And the regression equation now gives us y equal to minus 1.44 plus 11.45x. So this is what we have just calculated using the formulas that we have here. Is that okay now?
So far, so good, doctor.
Okay, I'm glad to hear that. So now we have demonstrated correlation, we have demonstrated regression, we have demonstrated confidence interval. So which are the main topic we were able to cover on Tuesday? For multiple regression, because if you want to do multiple regression, you will find having gotten the slope, you will need to find having gotten the slope for each independent variable. So that will make it so clumsy. But for you to be able to know how linear equation can be expressed, and now we can get the slope and the intercept. So we will do multiple regression using SPSS. I know SPSS can do multiple regression. I'm not sure about Excel on multiple regression, but I know SPSS will give us, so that when we are using SPSS, we will make the independent variable to be more than one. So we have multiple independent variables. One dependent variable will be depending on a lot of other variables. So we can use it. So we now get the slope for each of the independent variables. Then we can now express their equation as well. So now, normally, for class sake, if you are going to do regression, you will not go beyond one dependent variable, one independent variable. A kind of a linear relationship like this. Is that okay?
Doctor, when will we learn the SPSS?
Hopefully, let's see. It's possible. I will check the topic for next week. If I can put in SPSS there, so that I will demonstrate the usage of SPSS for you, because capturing data into the SPSS format matters.
So do we need to download SPSS?
I need to introduce you to SPSS, so that when you find maybe during your data analysis, when you are doing your project next semester, if you are to use SPSS, you will know the steps. And even if somebody else helps you to do it, you will be able to interpret the result that is coming out. So and later in life, you might be engaging in research study like us. It might not be academic research, it can be market research in the industry. You may need to use such a program. It's just to let you know, introduce you to SPSS, and how we use it to analyze. At least SPSS is for statistics. Is that okay?
Okay.
Yeah, hopefully I will check the next topic we have. If we have covered enough, I bring in introduction to SPSS. I didn't want it to be the last topic. So next week we can do, I will try and put SPSS on, maybe during tutorial next week. That would be good. Next week is possible. So is that okay? So any other question? I think the Tuesday again. Is it better now? Now that you have demonstrated by calculating from the first principles. Is it okay now, or somebody is having problem with it?
Okay, doctor.
Okay, thank you. So, please mark your attendance on Spectrum. We still have time today.
Doctor, just
Yes.
some question. Could you rearrange your spectrum document, because it's quite messy there. We have I'm kind of lost track on those document already.
There are a lot of documents there, right?
Yeah, too messy. Sound like it's very complicated. Repeated.
Anyway, I will see what I can do. If I see those ones that are old, maybe I'll delete them.
Okay, thanks, doctor.
Because it was initially created by Sir Abdugani. I was just fixing my own slide into my topics. Okay, but I will look at the old ones there and remove them so that it will be a bit clearer. But my week is week 1 to 7. We will be having our test when? When is our test? Week 7? Is it week 7 or week 6?
Week 6.
Week 6?
Yes, week 6.
That means immediately we come back from mid-semester break. Because after next week, we will go on break, right?
Yes. So, doctor, which topic will be tested?
Don't know yet. I'm looking at using your test. You know, test is 30%. Do you know?
Yes, we know.
So, and it's a big mark. So I'm thinking maybe we'll use the earlier topics. Maybe the test will cover the earlier topics we treated. So, and it might be 2 questions.
Handwriting or computer price?
I prefer calculations. Because that is where you demonstrate to me that you remember the formulas and you can do it on your own. So it's not memorizing or copying. This is an online test. If you are to write stories, you can open books and it will become an open book. Do you open book test? So I will prefer for you to demonstrate knowing the formulas and knowing how to calculate. Even if you are going to be looking at the formulas when you are doing it, you know there will be time constraint. Just study it, because when you get to the industry, ability to do it is not you memorizing or telling anybody about it matters, but your ability to be able to lay your hands on it and do it fine. So I would prefer the calculations. Does that answer your question?
Yes, doctor, thank you.
Yeah. Any other question?
But we hope that the test is easy.
Just as it's easy, just as we do, just look at what we just did today. When we are on Excel and we are multiplying, adding, you know, it becomes easy. Same way, when I say find mean, median, mode, or find mean, find standard deviation, you know, you just have to begin to multiply and get your data. And In calculations, you know, answers are not always the same. There could be differences of decimal places. So it is clear that you are doing something. So I'm not sure it is going to be difficult. I will not set a difficult question. Is that okay?
Okay, Doctor.
So thank you. So if there's no more question, we can end the class. Mark your
Doctor, will you
Yes.
upload the alpha on Spectrum, this X alpha? Because I think we need to revise back on the calculations.
This one,
Yeah.
I will. Yes, I will send it to your Spectrum. This Excel sheet.
All right.
Maybe
Okay,
later
thanks a
today
lot,
or
Doctor.
tomorrow, I will do that.
All right, thank you, Doctor.
Thank you. So don't forget to mark your attendance and always stay safe. So we can end the class. If you are no more question, you can leave the class after marking your attendance in Spectrum.
Thank you, Doctor.
Thank you,
Thank you.
Doctor.
Thank you all.
Doctor.